Welcome once again to my channel Blue Chip Finance. In this video, we are going to practically calculate problem of PERT CPM. So in previous video, as we discussed about the PERT and CPM theoretically, but in this video, we will see that how can we calculate critical path and how can we draw the network diagram, how can we use the probability in PERT and CPM to complete the project within a time frame, and we also discuss about the average and variance of time consumed of or expected time consumption within the project. So here we take one problem or example to discuss this whole phenomenon, that consider the following table of the project. On the left hand first column, activities are mentioned, and in the next column predecessors are mentioned, and in next three columns weeks duration in weeks are given: optimistic time, most likely time, and pessimistic time. And question asked are: draw network diagram, find the expected duration and variance of each activity, find the critical path and expected project completion time, and finally it is also asked that what is the probability of completion the project on or before 22 weeks. So it is one very brief and detailed questions related to the practical calculation of PERT CPM. So first of all, first question, that is draw the network diagram. So as you are seeing here that activities A, B, C are given and there are no predecessors against these activities. So just simply draw three different paths originating from node 1, path A, path B and path C, and these three paths are representing activity A, B and C. It's up to you, either you use this sort of diagram or diagram maybe according to your own choice. There is no restriction to make diagram in some specific manner, so it is totally up to you. So I choose this style of diagram, that first of all I draw three activities and these three have no predecessors. So what next? After C, D activity is starting from where A activity ends. So that is the logic to draw the diagram accurately. So D activity is starting from A activity is ending. So A activity is ending from here, node 2, and from here D activity is starting. After that, here you can see that E activity is starting from where B activity is ending. So E activity is starting from node 3 where B activity is ending. After that, F activity is starting from where C activity is ending, and G activity is also starting from where C activity. So at the ending point of C activity, there are two activities, those are starting, one is F and one is G. So at the end of C activity, there are two activities, F and G are starting. And why we join this F activity here? uh, F activity, where EF is ending, from where E and F activity is ending, H activity is starting. So that is why we joined E and F here, and from here H activity is starting. So after that, I activity is starting from where D activity is ending. So I activity is starting from D activity is ending, and finally J activity is starting from where H and G activity is ending. So J activity is starting from where H and G activity is ending. So that is the way to draw the network diagram, and my recommendation is that always use lead pencil first to make the diagram. Maybe there is a need to rub your diagram several times and make once again, so always use pencil, and after that when you confirm that your diagram is okay in all aspects, then you can make it with your pen or any other instrument. So next is find the expected duration and variance of each activity. To calculate the expected duration or mean duration and variance, you need duration, optimistic time, most likely time and pessimistic time, and activity. And now we will see that how can we calculate this. So these are activities in first column, and after that there are three columns representing duration in weeks, optimistic, most likely time, and pessimistic time. And there are two formulas to remember. One is for average and one is for variance. For average, formula is optimistic time plus 4 multiplied by most likely time plus pessimistic time divided by 6. So here formula is applied, that your optimistic time is 5 plus 4 multiplied by most likely time and plus pessimistic time divided by 6 equals to 6. And for second B activity, your optimistic time is 1 plus 4 multiplied by most likely time 3 plus pessimistic time 5 divided by 6, and so on. In this way you can calculate the average of all the activities. So for first activity, A activity, average time expected is 6. For B activity 3, C activity 4, and so on. And dispersion of the time, or simply variance, we can calculate variance through this formula, that pessimistic time minus optimistic time divided by 6 raised to power 2. So what is your pessimistic time? 7, and your optimistic time 5. So 7 minus 5 divided by 6 raised to power 2 equals to 0.11, and 5 minus 1 divided by 6 raised to power 2 equals to 0.44, and so on. So in this way you can calculate average and variance. So what is the third requirement? Find the critical path and expected project completion time. So here I break this diagram into 2-3 parts, but in fact you can make it at single one instance. So why I break this diagram? To better represent you visually. So first of all, to calculate the critical path and expected project completion time, we have to note down the average time used for each activity. So here average times are calculated 6, 3, 4, 2, 3, 5, 3, 5, 5, 3 against each activity. So we just write down here from activity A to J, and after that we just copy the previous diagram once again, and we just mentioned first of all average time consumed by each activity. Activity A consumed 6 hours average, activity B 3, activity C 4, 6, 3, 4, and so on. So in this way, first of all, you just write down the average time which is expected to be consumed in each activity. After that, now what next? Next, we have to calculate two things more. One is earliest start time or forward pass, and another one is latest completion time or backward pass. So first of all, we are going to calculate earliest start time or forward pass. So when we go forward, we start from the origination point, and when we go backward, we start from the ending point. So first of all, just observe lower rows of each calculation and ignore above rows, and you will focus when we will discuss to calculate the backward pass. Then you will have to observe the upper rows. So first of all, first node is always started from 0, and now just add up the average time taken by the activity into previous total. So 0 plus 6 equals to 6, 6 plus 2 equals to 8, and 8 plus 5 equals to 13. Here we mentioned 8 plus 5 or 14 plus 3. Why we noted here 14 plus 3? Because there is another path which is ending at here. So the maximum total we will write down here. So 8 plus 5 is equals to 13. But if you see from here, 14 plus 3, it is equal to 17. So we need maximum. So that is why we just ignore this and write down this 17. So this path is completed. And now we come to this path, that from 0 to 3 equals to 3, and 3 plus 3 equals to 6. But here one another path is ending here. So we will focus from here now. 0 plus 4 equals to 4, and 4 plus 5 equals to 9. So now you can understand that 3 plus 3 equals to 6 or 5 plus 4 equals to 9. Which one is maximum? So obviously 9 is maximum. So that is why we just focus to 4 plus 5. And similarly here, you can see that from here, if you see that 9 plus 5 equals to 14. But if we take from here, then 4 plus 3 equals to 7. So that is why 4 plus 3 is ignored here. So 9 plus 5 equals to 14, and 14 plus 3 equals to 17. So that is the way that we can calculate earliest start time or forward pass. Now we come to the calculation of backward pass. So how can we make the backward pass? Maximum forward pass should be taken now in the above row, and maximum is 17. So 17 minus 5 equals to 12. In forward pass we just add up, but in backward pass we subtract the average time taken by the activity. So 17 minus 5 equals to 12, and 12 minus 2 equals to 10, and 10 minus 6 equals to there are another activity which is possible here. So when we calculate that activity, then we decide that what should be present here. So after that, now come to the this point. So 17 minus 3 equals to 14, and 14 minus 5 equals to 9, and 9 minus 3 equals to 6, and 6 minus 3. So that is the second possibility. Now we come to this side, that 17 minus 3 equals to 14, and 14 minus 3, or here you can see that 9 minus 5. So 14 minus 3 and 9 minus 5. If we calculate 14 minus 3, the result is 11. But if we calculate 9 minus 5, the result is 4. So 4 should be taken here. Here one thing is very important. When you calculate forward pass, the maximum activity time should be calculated. And when you calculate the backward pass, the minimum time or minimum sum should be observed. So if 14 minus 3, it is equals to 11, but 9 minus 5 equals to 4. So 4 should be considered here, and 4 minus 4 should be equals to 0. So 0 must be ended here. And another point, that activity for forward pass should be started from 0. Third important thing which you must observe while calculating the earliest start time and latest completion time is that when you calculate the forward pass, you should observe the maximum sum, and when you calculate the backward pass, you should calculate the minimum sum. So in this way you can calculate the earliest start time and latest completion time. I think you need to observe this part of video 2 or 3 times, and then you should calculate by yourself to get expertise in this type of calculation. So after that, theoretical, which we discussed earlier in this video, is written down here, but I think that through practical following you can better understand to calculate the earliest start time or forward pass and latest completion time or backward pass. So now what next? Now we have to calculate the critical path. What is critical path? Critical path is the longest path to over this project. So there are many possibilities. One, as we are seeing here, that we want to reach the ending node 8. So what are different possibilities to reach this node? One is that you take start from node 1 and go to node 2, and from here node 5 and node 8. And another possibility is starting from node 1 to 3, 3 to 6, 6 to 7, and 7 to 8. And third possibility, that you take start from node 1 to 4, 4 to 7, and 7 to 8. And one another is 1 to 4, 4 to 6, 6 to 7, 7 to 8. So you need here the longest path. For example, if we observe first path, then 6 plus 2, 8, 8 plus 5, 13. In the first path, you take 13 weeks to complete this project. In second possibility, if you follow this path, then 3, 3 plus 3, 6, 6 plus 5, 11, 11 plus 3, 14. So in this way you expect that through this path you should consume a maximum 13 weeks, 14 weeks. Third possibility, that if you follow this path, then 4 weeks plus 3 weeks, 4 plus 3 7, and 7 plus 3 10. So through this path you calculate 10 weeks. So 14, 14, and 10. And what is the next possibility? That you go through this direction. Then 4 plus 5, 9, 9 plus 5, 14, and 14 plus 3, 17. So that is your critical path. Critical path is your longest path to complete the project. So that is we here place double arrows or double lines to identify the critical path. So that is your critical path. Here we already discussed in the previous slide, that is what is your critical path. 4 weeks plus 5 weeks plus 5 weeks plus 3 weeks equals to 17 weeks. So that is your critical path. Now fourth part of the question, that what is the probability that project should be completed on or before 22 weeks. So here first of all just focus your critical path, and your critical path activities are C, F, H and J. C, F, H and J. And what are your mean on these paths? So mean time is 4, 5, 5 and 3. 4, 5, 5 and 3. And after that, what is your variance on these paths? C, F, H, J. So we just go to the variance calculation table. C 1, F 1.77 and H and J 1, 1. So 1, 1.77 and 1, 1 are your variance on this critical path. So 1, 1.77, 1, 1. So total of variance is 4.77 and total of mean is 17. So now just apply the formula that probability that project will be completed on or before 22 weeks equals to x minus mu divided by standard deviation. Standard deviation is simply the under root of variance. So x is your desired time or observing time, that is 22, minus what is your mean, 17, and variance is 4.77 and 2.2893. So now just go to the Z distribution or normal distribution table and locate the 2.28 value. So 2.2 should be observed in the row and 8 should be observed in the column. So 8 here value is 0.9887. So 98.87 is the probability or chance that you will complete your project within 22 weeks. So that is the question related to the practical calculation of critical path, average or variance, and probability is also used in this question. And after that network to draw of network is also used in this question. So I think you have to focus 2 to 3 times to calculate this whole procedure by yourself. So stay blessed, take care of yourself and other persons around you. Thank you.